Hi everyone and welcome to this video about quadratic inequalities. Before we begin the video, please remember to like and subscribe if you enjoy it. And remember, you can always comment down below any questions you have about the video, or if you would like me to make a video on another topic for you, please leave that in the comment section down below as well. Before we begin with quadratic inequalities, it's important that you understand how to solve linear inequalities. So if you don't, I'll link a video down in the description, and you can study that first before moving on to quadratic inequalities. Let's take a look at this example of a quadratic inequality together. When I deal with quadratic inequalities, the first step that I take in my head is to treat it just as an equation. We're going to temporarily ignore the inequality sign for now. Once I've done that, I can solve this just as I would a regular quadratic equation. So here I'm going to factorize. So after I've got my two brackets, I can now set each respectively to be equal to 0 and find that x must be equal to 4 or x must be equal to -1. However, I can't be sure at this stage that x is greater than 4 or less than 4, or whether x is greater than -1 or less than -1. The next step is to do a quick sketch of a graph. So I take my quadratic, and rather than setting it equal to 0, this time I'm going to set it equal to y so I can plot it on my graph. Once I've done that, now let's draw it on. What I get is a curve that looks like this, and the two intersection points are going to be the solutions that I found earlier when I set the quadratic equation equal to 0. Once I've done this, now I can go back and look at the inequality sign. In this case, it says that my quadratic is greater than 0. On the graph, I set my quadratic to be equal to y. So in other words, what I'm looking for is sections of the graph where y is greater than 0. Now, where on the graph is y greater than 0? Well, that is the sections above the x-axis. So what I'm going to do is just put a little tick next to the sections that I want. Those are the sections where y is greater than 0. Now I can represent those with inequalities. So I have that x must be less than -1 in order to satisfy this region to the left of -1. And for the region to the right of 4, well, I need x is greater than 4. So my solution for this question is in fact two separate regions. And I can represent them with these inequalities here. Let's take a look at a second example together. The first thing is to rearrange our quadratic inequality to have 0 at one side of the inequality sign. Once I've done this step, same as before, I'm going to treat it now as an equation. The next step is to factorize, and now I can get my two solutions for x. Once I've done this, it's now time to do our sketch of the graph. Here's my line. I'm going to need to add on the intersection points. Now we're going to go back and see what our inequality symbol actually is. We can see that it sets the quadratic to be less than or equal to 0. On our graph, we've plotted y equals our quadratic, so we're looking for sections of the graph where y is less than or equal to 0. And on this graph, it will be the section here, below the x-axis where the y values are negative. So now it's time to represent the final answer with an inequality. So our final answer is -3 is less than or equal to x, which is less than or equal to 5/2. So just to summarize the few key points for working out quadratic inequalities, the first step is to rearrange so that one side of your inequality is 0. It doesn't matter what symbol or which side of the symbol is facing the 0, as long as you've rearranged it so that one side is 0. The second step is to treat your new inequality as an equation, either by factorizing it or by completing the square. Find the two solutions, which will be the roots of the equation. The next step is to draw a sketch of the graph. I would draw a sketch setting our quadratic equal to y. Remember, this is the quadratic that we find after step 1. And the final step is to use our inequality to determine the correct region of the graph, trying to find where y needs to be, whether we want positive y values or negative y values. And then we're going to represent this region with a final inequality, which will be the solution for our question. Let's use those points again and just do a quick example together. So setting it equal to 0 and factorizing. We find x is minus 4 over 5, or x is minus 1. Drawing on the intersection points, we have minus 1 here, minus 4 over 5. Now going back to the original inequality, we want the sections that are above the x-axis greater than 0. So it's this section and this section, representing with an inequality. We want the sections where x is less than minus 1, and the section where x is greater than minus 4 over 5. If we get a question with quadratic inequalities that has two inequalities, well, much like when we're doing linear inequalities, we're going to need to plot both of these graphs, then determine which of the regions satisfies both of the inequalities. We're going to treat the quadratic inequality like we have been doing so far, setting it equal to 0, and finding the solutions. We're then going to rearrange the other equation, which is a linear inequality, into a form which we can plot. So I've taken that linear inequality and I've rearranged it into a form where one side is 0. Now that I've got both of my inequalities with 0 on one side, I'm going to set the 0 side to be equal to y and plot them on a graph. So here are my two lines on the graph. Now it's time to determine which of these regions I actually want. So going back to the quadratic, I can see I want the section where the graph is less than 0. So it's this section here. For my linear inequality, I also need the section that is less than 0 as well. So we can see that that begins at this point here and extends downwards to the left. So the solutions that are going to satisfy both of these conditions are going to be between this point here and this point here. We just need to work out where they cross the axes. Well, we've done this already for the quadratic, and where my linear inequality crosses the x-axis is going to be 10 over 2, which is 5. What I've done is I've taken my linear inequality and set it equal to 0 and solved to find the value of x. So the values that satisfy both of these inequalities are in between the two dotted lines, so the smaller value is 3 and the larger value is 5. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.